Now we're going to review the numbers in base 10 standard 6, which is division, and I'm going to go through all three of the strategies that were taught this year. The first one we're going to cover is the lucky 7, also known as partial products. And just like our multiplication problems, we're going to use the same exact problem for all of the examples so that we're all on the same path. So our dividend is the number that gets divided, and it is going to be 7,368. And it is going to get divided by our divisor, which is the number that does the dividing, and it is going to be 13. And the very first thing that we're going to want to do whenever we do a division problem is we are going to want to find the multiples of our divisor so that it's easier for us when it is time for us to figure out how many times a number goes into another number. So we're going to figure out the divisors, multiples down the side, and multiples is when we skip count. And we're going to have 13, 26, 39, 52, 65, 78, 91, 104, 117, and we only go to 9, and that is because the greatest digit you can have in a place value is 9, so we only go to 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and in order to do the lucky 7, we draw a lucky 7 box that looks like a 7. We place our dividend on the inside, which is 7,368, and we place our divisor on the outside, which is 13. And the way that we do this is we start at our greatest place value, which in this case happens to be the thousands place, and we cover up the other numbers behind it, the other digits behind it, and we think, how many times can 13 go into 7? Well, we look over at our multiples, and we see that it can, because 13 is bigger than 7, so it cannot go in there. So we move to the next one. And now we have 73. Instead of having 7, we have 73. And we think, how many times can 13 go into 73? And we look over at our multiples, and we see that it can go in 5 times without going over. So if it went in 6 times, it would be too much because it would go over. So it can go in 5 times without going over. On the side, we write 5. But we think about how many numbers we were covering up. Just like when we talked about powers of 10, we are going to multiply 13, not by 5, because we want to take out big chunks. The whole purpose of this strategy is to take out big chunks of numbers. So we're going to look and think, how many digits were we covering up? And it is 2. So instead of being 5, it's going to be 500. And we go 5 times 13 equals 65. But we didn't multiply by 5, we multiplied by 500. Then we subtract. We go 8 minus 0 is 8, 6 minus 0 is 6, 3 minus 5, we cannot do it, so we have to regroup and borrow. So we take a group of 10 out of this, and we add 10 plus 3, which is 13. We go 13 minus 5, which equals 8. And we go 6 minus 6, which gives you 0. And then you do it all over again. You go and you cover up the 2 digits, and you think, how many times can 13 go into 8? Well, it can't, so we move over. How many times can 13 go into 86? We look over here, and it could go in 6 without going over. So we're going to put 6 over here, but we have to think, how many numbers are we covering up? We were covering up 1, so we're going to multiply by 60. 6 times 13 equals 78, but we didn't multiply by 6, we multiplied by 60. So we have 780 We subtract it. 8 minus 0 is 8. 6 minus 8, we can't do it, so we have to regroup and borrow. We take out a group of 10. We go 16 minus 8 is 8. Then we do it all over again. We look and we think, how many times can 13 go into 8? Well, it can't. So we go over and we go, how many times can 13 go into 88? We look at our multiples. Again, it is 6. This time it's just 6 because we're not covering up any numbers. So we go 13 times 6 is 78. Then we go 8 minus 8 is 0. 8 minus 7 is 1. So this is our remainder, and we know it's a good remainder because it is smaller than our divisor. If a remainder is bigger than our divisor, it means that we didn't take enough out. But we know that this is a good remainder because 10 is smaller than 13. So this number becomes our remainder. And then we add up all of these quotients out here, the numbers that we took out. 6 plus 0 is 6. 6 plus 0 is 6. 5 plus 0 is 5. We have 566 with 10 left over.